let's start with company update.
It's new meeting 30. Yeah. We did the AMD conference last week. We got a nice Lego set. AMD likes us. This is good. It's good. Progress on the big deal. We're hopefully gonna get to MI 350p cards soon as well. We'll be able to prototype RDNA 4 kernels on machines that boot fast. And yeah, nothing else too much happened. A lot of people are interested in mega kernels and like ways to synchronize between CUs fast. This seems to be the limiting factor of mega kernels because you use atomics and they're really slow. A lot of people are talking about lots of different kinds of parallelism: expert parallelism, data parallelism, tensor parallelism, pipeline parallelism. So hopefully we build a framework that just kind of incorporates all of that. Yeah, kind of it.
Great. Sounds good. I think we'll also know better once we have different kinds of it. All things running using different parallelism. With that, let's move on to GPT OSS training.
I mean, hopefully we don't need to use any other parallelism for GPT OSS other than data parallel.
Oh yeah, for training it should be good.
So we have a trained run, converged run. It is at 2.5 seconds a step, and then I posted the correct step breakdown. Most of it is just MOE routing.
What do you mean routing?
What do you mean by most of it?
There's a lot of time currently wasted in MOE routing. It's per token, you have to get top 4. Like you have to run the MOE router per token and then run gradients.
Oh, maybe it's a good idea to rewrite Gather using index now.
Is that what it's slow? I mean, what does MOE routing even mean? It's on the same GPU, right? It's not like we have any expert parallelism.
Yeah, no expert parallelism. It's just the way that's currently written is a pretty slow gather. Fairly slow. Just it's a huge copy basically because you're copying the activation.
The activation or the weights?
Because the MOE kernel, you can't drop experts. You essentially have to do a sort. And you copy the activations.
Why do you have to copy the activations? I see why you have to do a sort.
Yeah.
But why do you have to copy the activations?
No, just right now, Tinycorp is generating a bunch of copy kernels that are not needed.
Yeah, but are you sure it's the activations being copied? That doesn't make sense. I understand why the gem might. What?
It is copying the activations, but what should happen is the MOE kernel should just read a list of indexes. It's because right now, the way the MOE gem kernel is written is that it expects stuff to be bucketed already.
It expects stuff to be bucketed, but I still don't understand why it's copying the activations. I would understand why it was copying the weights, because the weights it would change is based on what expert you select. If it's really just gathering the, it's really just copying the activations. I think that's a bug.
Yeah, I
think you're doing a slice, right? You're like
MOE
slicing this and passing the gem.
No, it is a gather over the activations. It is just a poorly written MOE gem kernel. I have a newer one that I'm testing that basically gets rid of all the MOE routing.
I see. Okay, yeah, I guess I don't exactly understand why it's the activations, but yeah, okay. If you think you know how to fix it, yeah, I think before we start trying to make the gems faster, those first 3 categories just look like stupid.
Yeah, a lot of it is kind of stupid. And then
yeah, those first 3
a lot of that reduce bucket is sliding window attention because our flash attention kernel doesn't support that yet.
Oh, I see. That should be faster though. Cool.
Is this a master?
I have one more thing left to merge into master, and it's like the big MOE gem kernel. I still need to clean that up, and then I should merge it sometime like this week, like early.
And can I run this with null backend to see how many RAMs and kernels it use?
Should be possible. I will
Now, once you have that, it's probably a good idea to put that on CI or somewhere.
Yeah.
So what step time do we need?
0.5?
We need 540 milliseconds.
540 milliseconds. Okay, so if we just delete the 3 stupid things, it seems kind of good.
540. Does that get us there?
Probably not, but that's a
Not
good start.
including the 300 milliseconds of not accounted for time.
Oh, well, yeah, I don't know where that time's going to. That's more stupid time.
We can also make the machine cooler.
That too.
That's questionable. Well, it may not be doable. And also, that may not even really be the problem. We'll get to that when, yeah, we'll get to that.
Okay, sounds like a good progress. Anything else?
We all.
Okay. Next is my stuff. So for the tensor mixing, I move to last thing in making the where, and I really forget what the other one was, but where was the last one? That was done by fixing expand to not expand all the time, basically make it expand implicit. So where just works nicely at the tensor graph level and in the late UOP level. Then most of the time was working on the weak D type. The current progress is for the things like I merged already. If you look at the D type from UOP, read a const and infer its D type as weak int, weak float, or boolean from its argument directly. And we have another function called from_pi, which is the interface between a Python const to a tensor const that I also flip to use the weak and bool. So what's remaining in our pipeline that still generates a non-weak const is we have some rewrite rules that would generate that, especially in the late decomp, in decomp D type and decomp the transcendental stuff, basically, that still regenerates the weak D type. And once I fix all that, we shouldn't have any concrete type or const, which should happen sometime this week.
Great.
Yeah, this was I just fixed a bunch of stuff. We have a lot of places that we have weird spec that I try to fix. So for this whole project so far is line neutral, slightly down. So I think that's a good sign that it's not crazy, and I just need to make sure because we say we need to reinsert some of the type to make the backend work. Some backend still want you to specify the const when you render the literal of that const. So we need to know what that needs to be. Otherwise, the backend will assume weird stuff and do the weird broadcast, like upcast for you.
Not sure. I mean, you can just like match the render on a cast const.
Yeah, we still need to do that step right before decomp D type. Otherwise, you might later rewrite that into a D type that you don't actually support for your render.
Okay, yeah. So you want to make them all explicitly casted. Okay, yeah.
Yeah. So that step needs to happen before decomp D type, and we need to make sure decomp D type itself won't regenerate a D type that it doesn't support.
Yeah, but this actually needs to get deleted from UOP.
Yeah. So.
And then also I'm gonna look into removing the meta class once D type's gone. It's not really related to D types removal, but
Yeah.
meta classes are slow, and if we can do it in new,
And we
a lot
also have
better.
a crazy line there with a to do that basically check
Yeah.
spec.
Yeah.
Okay, yeah, so that went nicely. I also started to I was interested in the P-contiguous, or basically the high level scheduling stuff that happen around Rangify. That is similar to how we auto discover like softmax backward the max. You can cancel that, and some of the scheduler higher level scheduler stuff that's kind of interesting to look into. I have 2 drafts in the PR if you're interested. I also fixed a bunch of Torch backend stuff. It's something that I don't really know if we want to support or not, but it's fun to improve that, so I improve that. I almost got Torch compile working, which is pretty
Yeah, I
interesting.
mean, I think we want our Torch backend to work because it gives a really nice apples to apples comparison. Like, we should just be able to run Torch repos and.
Yeah, so that would be nice. But before that, I found like 5 different bugs in the old stuff. So if we want to support that, we also need to improve that.
I mean, that's a real way to get Tinygrad users too. Or, like, everyone should just have Tinygrad installed in their system. Oh, we should do a release soon.
Yeah, let's do a release. Maybe I don't know. Maybe when? After Chestnut launch, probably.
Yeah, we'll do it with the chestnut launch.
Yeah.
That's good.
So that we make sure it works with whatever Tinygrads we have.
Yeah. I'll try to get some of the LLM speedups merged too. We'll have some out of the box chestnut. Yeah, we'll have some out of the box chestnut bench numbers that look pretty good.
Great, sounds good. Okay, that's my stuff, and we can move on to Chris stuff.
Yeah, so slice is almost done. Last thing I need to do is get 64-bit UOP variables working.
Did my stuff help?
That doesn't apply for UOP variables, but it should help for.
No, but just help with slice.
Yes, it should help for the other copy stuff.
Right.
Yeah, that's
Yeah.
another blocker, not blocker, but the things I noticed when I do the weak D type stuff, because we hard coded several things into in32 and uin32.
Yeah.
So that it works, but
Yeah.
it couldn't be.
Yes. And that kind of fits well with the program class changes.
What do you call the new program class?
Well, the program class is called program, but the thing that you pass around it's called Tiny Elf.
Tiny Elf!
Anyway, yeah.
Where is Tiny Elf merged or?
It is,
Yes.
Oh, sweet.
And
Could it be old capital?
that implies that the tiny part stands for something. Actually, it's not really like the elf part.
Oh, that's the exact. Oh, I love Tiny Elf. Oh, it's my favorite. Wow, it has a signature. Wow, this is the most convenient. What's a target?
That's like dev equals.
Oh, all right, cool.
Yeah.
I haven't read this code.
Anyway, that should be useful. I don't know exactly what the implications for that are for HTQ2 because HTQ doesn't have a program class. But generally, it should be nice to have that be a little bit more unified.
Why is there a device type separate from the Tiny Elf? Why is there a dev here?
What?
In program, why is there a dev and a Tiny Elf?
Because a lot of the program classes depend on having access to the device to do allocations or
Having access to the real device.
yeah.
I should really stop calling it compiled. That's a pretty stupid name for the device.
Yeah.
Yeah. They're compiled devices. All devices are compiled.
Yeah.
Yeah. Why isn't that class just like called device? Oh no. Also relevant to HTQ2, I guess we'll get to the next, but like, yeah, we're gonna delete the. Can I explain what we're deleting?
Wait, what are we doing?
The offsettable buffers.
Oh yeah. Yeah, so the idea is that I'm gonna try and remove underscore offset from the allocator. And this kind of fits in with the slice stuff. But I think this has some implications for copy. I think copy in and copy out will probably need to accept offsets. Or you can just track this all in the buffer object, but then not have it be an offset, like not have it be like a separate
No, copy
allocation.
just has to accept the objects. I think copy just has to accept the offsets, right?
Yeah.
Like you can see how I've moved toward that. There's like a compiler now for copies. Like we just have a compiler for SDMA, and SDMA can support offsets.
Okay.
Right. It's basically like the HTQ compiler.
Yeah, that makes sense.
Right.
Yeah. Anyway, yeah. So underscore offset shouldn't exist anymore, which will be nice because WebGPU and CL don't support it.
Like in theory, we could still implement offset, right? There's no reason that we can't put the add outside of the kernel.
Yeah.
But or the shrink outside the kernel and have the renderer be able to HEQ to renderer be able to do it, but it shouldn't be on the buffer class.
Yes.
The offset has nothing to do with the buffer. Like that's just in the wrong place.
Yeah. Anyway, in any case, yeah, I don't. That also probably has implications for HCQ too.
Then we had like sub buffers and alias buffers.
Yeah,
and delete it all.
There's also like all the stuff for tracking whether or not you're allowed to free a buffer or not because you might have sub buffers.
Yeah.
Anyway.
Yeah, I mean you could still implement it two ways, right? It can either be implemented on the in the program where you take in a variable and you add the variable using the GPU, or it can be outside in the graph and be compiled in HTQ2.
Yes.
But either way, offset has gone from buffer.
Yes. Yeah. Anyway, that is closely related to slice. Yeah. What else? Oh yeah, and then the PyTest timeout. That's just I just deleted PyTest timeout. And there's if you look in conftest.py, I replaced it with like a 5-line thing that does the timeouts and actually reports the timeout and also actually successfully times out because for whatever reason the signal timeout thing just doesn't work. So
Where's
conftest.py.
Is that like a known thing?
It's a PyTest configuration file.
Cool.
Anyway, if you see any issues with that, let me know. But interestingly, I have not seen any. I have not seen any timeouts since I made this change. So
Yeah, because I deleted a lot of slow test.
Okay.
Now test is very fast. It's like 3
No,
minutes.
but there was something I thought
let's
were
lower the timeout then.
Yeah. Anyway, you can
Wow, that's great. Wow, why does someone write a plugin for those lines?
Anyway, wait. There was definitely stuff that was hanging forever before. I was pretty sure it was hanging forever, and now.
Okay, maybe we fix something.
Okay, that's. Yeah, I guess it got fixed.
I believe that just works. Yeah,
That's basically what PyTest timeout was doing.
yeah, but probably had 1,000 lines.
Yep. Yeah, I think that's it.
Sounds good. Okay. With that, we can move on to HCQ2.
So yeah, I merged the CPU backend, which is now in UOps, and yeah. So for HCQ itself, I just landed a lot of optimizations. So the only reason why HCQ is not merged is the compile time. So actually, the problem right now is that, like for large schedules like real trainings, we generate pretty in not GTED steps. Like the first two, we generate pretty big C kernels, and they take a lot of time to linearize and then compile. So, so I've been thinking how to solve this. I don't know if I just want to rewrite. So right now they lower into the like PM4 and all these things are done using rewrite rules. So we just like rewrite some HCQ instructions to the real AMD instructions. So I don't know if I'm sure if I want to translate this to the UOPS and not to the rewrite rules, and compile like this PM program or PM4 weight as C as encoders like in C, and then just invoke them from the from the one program.
I'm not totally understanding this. I mean, so I'm reading the HQ2 code now. We want to get rid of compiled. So it should all just be like HCQ2 should be the only way. Like all devices need to fit into the HCQ2 framework,
Yeah.
including metal.
Yeah, but yeah, that should be possible, but that's like the full rewrite of backend, kind of.
Yeah, great. As long as the design decisions being made don't preclude that rewrite, right? Because like I still see classes like HCQ2 buffer and HCQ2 compiled, and those should be replaced by just buffer and compiled. I mean, I still need
Yeah.
offset too. Okay, so explain to me you're saying that the compilation of the C programs to do the submission is taking too long.
So yeah, so how this works right now is that for non-jittered calls, we just generate like one template of the PM4, like the comment buffer, and after that we need to patch it with the real like input buffers and addresses and so on. And this is done in C, like the C program does that. And for large schedules, there are a lot of things to patch in because of that. Yeah, just like 20,000 lines of C code.
So that patching being generated, is that patching requiring a call to the C compiler, or is that because the way that I made the AMD emulator fast was that I just turned all these parameterizable things into variables. Like there's one basic C program for each instruction, and then things like which VGPR it is parameterized.
Yeah, I mean, I can turn them into loops, but I need like to have like two inputs, like offset and value. And these can be loop then, and it should be fast.
All right, we have to be very, very careful with loop. If we have offset and value, that sounds a lot more like a scatter. I mean, it should just work as a scatter, right? Be very, very careful using loop. I'm going to take loop away if loop causes problems. You see what I mean?
No, no, that's not a loop. But yeah, I see.
Okay, great.
But
As
yeah,
long
I
as
mean,
we're,
but
as long as we're not
yeah.
doing something like looping and looking for zero termination or something.
Yeah, no, it's not loop. Like it's
Okay.
finite. Yeah. So, but my another idea, and I'm just thinking still about this, like if you open like opsamd2 and like PM4 program, so they just rewrite rules and they're still like in Python. So
Sure.
what if I just rewrite all these slowers in like uops, like ops CPU right now, and basically invoke them like Python does, basically. Python did already. But yeah, and then just I have one program and I just invoke all these lowers from C, so just to lower, like to encode something directly into the ring. So I'm using
Okay, so you're
call
saying
instead of patches.
you're saying that instead of using rewrite rules, you want to write programs in uops.
Yeah, and just have HCQ2 to just call these like small programs. For GTET, I can just actually I think this could be easy parallelable, both for like drivers and for
So
JIT.
we need to okay. Which is easier to maintain and more likely to be correct? I never care about speed. Like we should never ever do things to optimize for speed like that. Right? If there's a reason it's better to write the things in uops and rewrite rules, then that's justified. But if you're saying the only reason you want to do this is for speed, we should absolutely not do it.
Yeah, I see. I just yeah, okay, I'll think. I just don't really want to generate like all these offset and values because I just need to write this in Python and then just feed into the C program. So if I do calls, I think it's better.
Yeah, like it can be fine if what you're doing is you're using like, I mean, you say like write it in UOPS, but can you write it in tensor?
Uh,
The difference.
I can
Mhm.
try. Yeah, I
If
think
like
yeah.
the more we can write these things in ways that look like tensor manipulation, the better. If you're thinking about using UOPS like a programming language, like loop is really, really, really bad.
Yeah, but okay, for these programs we don't need loop. I think yeah, I can try them like in more tensor way.
Yeah, I mean, also like the only thing to focus on, never worry about speed. The only thing to focus on is maintainability and what's going to be easier for more people to write new ones of these.
Yeah.
So yeah, no, I mean it doesn't have to be like, so what rewrite rules are you specifically talking about? Like things like this call to like SDMA wait? Like
Yeah,
the
yeah,
SDM
yeah. So these that actually just lower to the like PM4 pockets and HDMA pockets.
Yeah. And it's using ins. That seems right though.
Yeah, but yeah.
Yeah, maybe I don't exactly understand what's slow. I mean, this doesn't look slow to me, right? This looks identical to lowering the program itself, right? Like this looks like an assembly backend for PM4 or SDMA, which I think is exactly what we want.
Yeah, but when I'm like the patching of these command buffers, because they have like some unknown values and some values which are known only during runtime and not during these building of these command buffers, like some input addresses.
But it wouldn't be these opcell pattern matches, because I think these opcell pattern matches are right. Which pattern matches would it specifically replace?
No, I wanted to replace these specifically. So like
I mean,
PM4 program, I wanted to rewrite these. Like PM4 program will be like the UOPS, like will be rewritten in UOPS, not the instructions. And when I lower like the program or the call operation, it will just invoke this thing to encode into the buffer which is passed in.
No, I don't. I really don't think we want that. I think that this isn't why it's slow. Like I can't understand why lowering a program with like, okay, so here's what I would do instead. Don't you still want it to be UOPS? But okay, yeah, PM4 program's the perfect example, right? So some of those things in PM4 program are parameterizable, right?
Yeah.
So you want to turn that into a call, but it still has the instructions. This is
Yeah.
this is the same problem as basically dealing with like when you have an instruction and you want to assign that instruction like to a register, and you have to like bit shift the register and put the register actually in the machine code. This is the same problem as that. So what we don't want to do is like writing something that looks like tensors that create the binaries, right? You could imagine that for assembly as well. You could imagine assembly like tensors concatenating machine code. We definitely don't want to do that. Like, we want it to go through a pipeline where we lower it as an ins instruction. However, what's slow here is the fact that you're calling PM4 program many, many, many times. This is the exact same problem I dealt with in the AMD emulator, So what you want to do is you want to turn PM4 program into a function or to a call that takes in the stuff as parameters. Does that make sense? Do you think that fixes it?
So they already like parameterized. Like I call program like once for the kernel. Like
You call program once per
Nice.
kernel,
yeah.
yeah.
So
I'm saying you can call it once per queue.
yeah, maybe yeah. But again, the problem is like the generated C like looks like that. It just
No, I totally understand. That's what I'm saying. Like it should be
Yeah.
a call,
yeah.
right? Like the way to fix this in C is to have so a lot of things can be fixed with hierarchy, right? So hierarchy is the square root if like in the limit, right? Like imagine having a function in C called PM4 program that like has all that stuff in it, and then it just passes in a bunch of parameters, and then in the main function you have like 10 calls to the program. Right? Like call should be lowerable.
Yeah. Yeah, so I think I wanted exactly that. So I just have like the like PM4 program like as a separate C program, and I just call it with some parameters, and it will just return me instructions, right?
No. Like it's not a separate program, it's just a call. It's like a function.
It's like how we write WMMA. We render those stuff. You want to generate.
WMMA is dealt with terribly. It's not like WMMA. It's like yeah. I'll write like some C. Like we want like PM4 program rams, right, and then like void kernel. I wish there was some way to type live like that.
Yeah, that's how we use WMMA.
Not how we use WMMA. WMMA is hard coded in the renderer. This should not be hard coded in the renderer.
The idea is there. WMMA should be like this.
Yeah.
But yeah, notably, in UOPS, what this should look like is like a call with like repeated PM4 program and then params. Like that. Do you understand how the AMD emulator works?
I haven't read it like in details.
Run some
But I will.
run some stuff through the AMD emulator because I dealt with a lot of these same problems. The main problem you run into there is if you're generating a program for each instruction, it's really slow because there's many different kinds of instructions. So I parameterized basically everything about the instruction. I didn't pass those parameters in. I just read those parameters from the machine code of the instruction, but it's still the same basic idea. You parameterize your PM4 program entirely. Like I see things aren't.
Yeah. So yeah, I just okay. So just to be short, I just want exactly the same. But do you want to put this into the same like the C kernel, or we can just compile because currently with like for the C backend we have call which can use pointers and just do external calls using pointers. So we
Yeah,
basically can do the same.
we should
Here,
modify this C backend to be able to render like normal functions.
Okay, yeah.
I think that's not too hard to do. So then, like, your return of PM4 program is an ops linear. Like, what's happening when you return that ops linear is it's then getting flattened down and then it's getting turned into this massive C program. So that ops linear should be an ops call.
Yeah.
For the PM4 creation program, right? So do you see how this is square root of n uops?
Um, s- yeah. I think yeah.
So I'm pretty sure this works. But definitely what we need to really avoid doing is manipulating machine code in TensorLand. Like, I know it's doable. Right, so this turns n squared into 2n. By factorizing like that.
Yeah.
And then, I mean, you can almost go even crazier with this and like you want like a scan operation. I think just this will be enough, but you could imagine what it becomes is a scan operation, which calls function one with parameters that are in a list or something, or in a tensor. But you could imagine scanning function one across a list of programs.
Mhm.
But, does this fix it?
Yeah. So yeah.
Cool. I mean, so is the slow one the PM4 program one?
I mean, this will solve the. Oh, I mean. So we just that's not the not the PM4 program. That's the amount of patches we do. In the final C, like it's not the HCQ which is slow. It's like the C linearizer is slow, and the compile.
What
But
file should I?
that's yeah.
What file should I look in for this?
It's not actually the file, but basically all these patches would like like you can see this C program. So the current idea is that all these instructions there will be like in the binary blob. So they're binary. This is like one store to write them into the real buffer. So that's minimal amount of jobs, but we have like patches for the addresses, like the kernel addresses, program addresses, and we should just in runtime we should replace them on top of these like the template we have, common buffer template, and that was slow, and not even in like in HCQ it was slow in like the C generation because there are a lot of these patches. So, but basically, calling like PM4 program in runtime should solve that. I think.
I see. I mean, okay, so there's another thing that you can do, which is like this should be pretty fast too, and it should render. Sorry, not adder, I mean offset.
Yeah, I see. Yeah.
That should work. If that doesn't work, we can all work on making it work. So that's basically like a scatter. And then if you want to actually like encode all those consts, like stack const is the way to do it.
Okay. Yeah.
If you want to do patches. Okay, cool. I mean, overall, I think that most of the decisions in here have been very good. But yeah, the way that we should really always be thinking about it is in terms of a assembly backend for the mech and for the SDMA engine. Yeah, no, they look. I mean, they look beautiful, and like we could like eventually, I could see us factoring this ops AMD 2 into like AMD PM4, AMD SDMA, AMD RDNA 3. It's all kind of the same thing. Different, a little different about what you can actually run. But yeah, then for these scatters, it should just be this. But I mean, these get into like other problems that we haven't totally answered yet, which is like, how are we going to do things like machine code generation with the registers, right? How do we know how to like put the register into the machine code of the instruction? Okay, R4 is the source input. Okay, we got to like bit shift 4, that kind of stuff. So that hasn't exactly been solved yet. But yeah, I can see these being sort of similar problems.
Okay. Anything else?
No.
Okay. Let's move on. You scroll a bit. Next is your stuff.
Cool. So I very regrettably wrote loop. It's very regrettable. Loop is so regrettable. I almost want to call it like loop underscore do underscore not underscore use. Because loop is Turing complete. So yeah, there's that. As soon as you have something that has an unbounded number of iterations, it's Turing complete. There's some more cleanup that can be done. So okay, the way that we express loop right now is with a sourceless range. So it's or a range as a no up source. So a range that has a no up source will not terminate, and then you put a termination condition on the end. So end has a termination condition, and that's where the loop exits. But yeah, so this is unfortunately Turing complete. Now, there's some things that you need this pattern for that you can't really get around it. We could always add a bound, right? We could always add a range bound. Oh, it's not time; it's loops.
Loops.
Yeah. We could always add a bound, and that kind of fixes it, but not really, right? But there's some things that you're going to fundamentally need this pattern for, right? If you're waiting for another device to finish something, I mean, that's basically the only time you need this pattern, when you're waiting for another device to finish something. Do you think why not use something like ops.wait? Well, the problem with ops.wait is presumably to check if you have completed it, presumably you have to poll on something, right, which is a load. But if you just put that load, if you do something like a load and then an ops.wait, the problem with that is that load is not in any kind of scope. So that load is going to fire once, right? This is like if the same problem if you don't put volatile in C, right? So like our loads, because we have a data flow compiler, our loads have to be scoped. Now, we already have machinery for scoping loads inside of a loop. So you can have a range and you can do after, right? You do the buffer and then after, and as after the range, you do the load, which means that every time that range loops, you'll do that load. So that's why I settled on this for loop and not like wait, because we need some way to scope what you load and what you don't load. So you kind of need 2 UOPs for that, and your 2 UOPs look an awful lot like range and end. So I'm going to just reuse range and end. But yeah, be very careful using this, and it's very, very bad. And if you're using it, it's very, very bad. Shouldn't need it for anything, but we can also use it for instruction selection. So a bunch of the backends, this just has to be cleaned up. If someone wants to like do this, I wish those people would just like do this, because AI do it very untastefully. It's just someone who would do this tastefully. Like the LVM backend, the PTX backend, the NIR backend, their code to express loops is a lot simpler than their code to express ranges. So a range basically includes 3 things. A range includes an initializer, a range includes a comparison, and a range includes an increment. But right now they're all just stuffed into this one magic op called range, but that can obviously be broken out, right? I just described 3 parts of a for loop. So yeah, we could have some backends that don't support for ranges with a no-op thing, and it'll simplify the renderers, which is great. In fact, we could do that with all of them, but it makes the C code uglier. So yeah, that's loop. Copy. So copy is store. I now lower copy to store. So copy is kind of like an anonymous store, right? You can think about like a copy from the AMD device, the CPU device to the AMD device, right? What that's saying is I want you to create a buffer on the AMD device and copy in from the CPU device. Now, There's nice advantages to buffers being anonymous. The biggest advantage to an anonymous buffer is if you do 2 copies on the same thing, those 2 copies you up dedupe to 1. Whereas if you do 2 stores, if the 2 stores are to different buffers, it's not going to dedupe. But with the disabling of just 1 test, that was a very contrived example. I switched copy to store, and then this simplified, like Rangeify never has to deal with copies anymore. Copy is re-added back at the end, but it's not really a copy op. The thing that I use to re-add copy at the end should actually become the HCQ2 AMD compiler. So the HCQ2 SDMA compiler, right? Because what that copy is basically doing is saying, like, I can run this program on the SDMA engine. And then this also gets into the, well, so that program actually doesn't have to run on the SDMA engine. That program can also run on CUs. There's no reason that CUs can't also implement a copy. So we have to get better about, like, saying, okay, right? You can even go crazy and say, like, this program is going to access buffers on AMD 1, but it's going to run on AMD 2. There's no reason that that shouldn't just work. So yeah, moving in that direction.
Also work nicely with multi.
Well, yeah, I mean, the multi, okay, so it's not invalid. Multi is something else, and by something else, I mean it's actually Rangeify. Multi is Rangeify. Is that written on the board? However, multi is not like the existing Rangeify. The existing Rangeify operates from the bottom up. The existing Rangeify takes an index op and moves it up through the graph. Multi works the other way. Multi lets us specify the axis at buffer creation time, which is at the top of the graph. So at the top of the graph, you say, I want basically this range. A multi is a range. So if I'm saying I want a chart across axis 0, that's a range across axis 0. That factorizes the top dimension of axis 0 out and does a range across it. Yeah. So the way to rewrite multi is to rewrite it as generic top-down Rangeify. I actually wrote top-down Rangeify once before. The problem you run into is it creates very ugly things for the convolutions. And you can, like, see why that is, right? So those things kind of, like, go away, but those things would fail on multi anyway. So it's not like you can't multi across the weight axis of a convolution anyway. That will fail right now. So yeah, I'll rewrite multi as top-down Rangeify, and then it'll be pretty generic. And then that range is this UOP called device num, but you could also imagine you can actually use any UOP you want for that, including the one that I really care about, which is the warp. And then we can express alloc fragment by running a top-down Rangeify. Yeah, so it's actually very similar. The code isn't going to be that different from multi. Like the code that we have in multi right now, which processes like the movement ops and stuff, it doesn't really go away. It just gets genericized and called top-down Rangeify. And instead of moving an index up through the graph, we move a stage down through the graph.
Great.
Yeah, and then this also answers the problem very beautifully of how we introduce all reduces. Right, so the problem with any of like the pad invalid stuff, why it doesn't work, the thing that like I could never really fix is like, okay, I can pad invalid, but then I do a reduce across the axis. That's not an all reduce, right? That's going to reduce it. Even if invalid is the identity and reduce, you're still not communicating across the devices, and it's not obvious to figure out how to communicate across the devices. But in the Rangeify, it's obvious. Right? In the Rangeify, if I am moving my range down through the graph, and that range happens to be on a reduce, great, insert an all reduce. Yeah, that's it. I'll work on multi more this week.
Anything else?
No.
Hey, next is Llama training.
So we can talk about the AMD on the machine slowness issue. We ran the AMD Docker. It's finished 16 minutes slower. So like we're 10% slower than AMD on the same Docker. and I really like tracked it down. It even went like went as far as like checking the voltages using BMC. It really comes down to our intake temperatures are too high and the clocks slow down. I have a repro of this. If you run a gem in a loop, you'll see that the gem gets less flops. So it's like it gets like 2% less flops
So
after a bit.
why I'm reluctant to believe this entirely is when you throttle the power, it only gets to 70C, but we still see a drop in the performance, right? That's not throttling.
It's not. So I checked the bits. AMD has like these bits for violations,
Yeah.
and the thermal is not set. The one that is set is called the PPT, the power package limiting. And it seems like when it gets to already at 1,000 watts max, it doesn't go up higher than that. And then it just, I guess the clock slow down. Like that's what I see in there. And I
Yeah, I
click
mean,
at them.
so you see the clock slow down even when it's only set to 500 watts. You said even at 500 watts, the clock slow down.
Yes, they slow down.
But why? They're not hot.
But it reaches the power limit.
Oh, the 500-watt power limit.
Or the whatever I set it to, yeah. So it reaches that ceiling.
I mean, again, that still doesn't explain really why it slows down after minutes. It should reach that ceiling immediately. The 500 watts, if you set it to 500 watts. I don't know. I mean, we're working on yeah, I think that we close this investigation for now.
We'll get a generator supposedly tomorrow. And
Yeah.
it will be loud here probably, and we probably won't fix the temperature anyway.
Let's be optimistic here. Okay, so we looked into buying an air conditioner, putting the air conditioner in the computer. We don't have enough power for the air conditioner, and everyone was opposed to my plan of a long extension cord. The rule at the office now is if you want power, you have to make your own power. So we have a generator coming here tomorrow, and Harold and I have $100 bet. He thinks the generator is an acceptable solution and will be quiet. I think the generator is going to be stupidly loud. So we'll see who's right. But yeah.
Yeah, so we will fix the temperature issue
Yeah.
later anyway, one way or another. But I think we can divert our energy back to like making Tinygrad schedule better kernel and render better kernels.
Yeah, we can table this for now. We will get you lower intake temperatures in a few weeks. They'll be on time for MLPerf. Seems like it's not anything else. So that is good. All right. So what other speed ups can we get?
All right. I have a list of tricks to merge into master. My deliverables for this week are merging a removal of contiguous from custom kernel. And I'm gonna work on the flash attention and the gem improvements that I discovered from just doing the profiling.
Are flash attention and gem written in HIP or the UOP language?
HIP
You think we can
is a
write them
HIP
in the?
event.
You think we can write them in the UOP language without losing performance?
I can look. I think it's gonna use a lot of ops custom because a lot of the reason why it's written that way is because LLVM is bad by default.
Yeah.
But yeah, you like use a lot of ops customs. Like it's not gonna look pretty. I don't expect it to look pretty.
I mean, maybe we want to think about just doing this when we get to assembly languages if there's no way to do it in LVM. I mean, the other thing is MXFP4.
Oh yes. So I have a run with MXF4. This
Is
is
it
the
fast?
one. The gem So the gem, there is no hip gem for FE4. I tried. It's not fast. It's 3 hours. But it's 3 hours not because the gems are slow. Gems get 5 petaflops.
Okay.
So
Well,
if I
but
take those
it converges in the same steps or more steps?
the same steps as AMD.
Oh, I see it. Wait.
Yeah.
The other one you linked converges in 1,000 less steps.
Same steps as AMD. So I ran AMD's FP4 Docker on
Oh,
our
okay.
machine, and I compared that step time.
How
Yeah.
fast was AMD's FP4 Docker on our machine?
How fast was AMD's FP4? I don't quite remember, but it's still 10% slower than their submission.
Yeah, I'm sure it's 10% slower in their submission, but I mean, we'll just operate in this world where we're just competing with the AMD Docker rerun on our machines and assume that it'll just get faster.
If at the end of this contract period, we really need AC, we'll just rent a machine or something.
If we get close to the end of the contract period and we need AC, I'm going to turn off half of Comma's data center or run a long extension
Yeah.
cord.
I was thinking of
Or
like
just rent your car.
getting a cloud with AMD's.
Or we can get a cloud with AMDs. Yeah. So why is the MXFE4 slow?
Dumb kernels
Dumb
and
kernels.
placement.
All right, great.
Yeah.
Yeah. Let's go faster.
Right. Yeah.
Are we beating AMD's FP8?
We're beating game. We're matching AMD's FPs.
We have a faster one.
You want a faster one for FP8 or?
Beat AMD's
Is the
FP8.
faster one?
Beat AMD's FP8 on master, and I'm happy. It doesn't matter if it's FP8 or FP4. Just beat AMD's FP8.
I'll beat it with FP4 because I have maxed out all the FP8 optimizations. It comes down to faster gem and flash attention, which I tried really hard to write, but doesn't really seems to be maxed out.
Wait.
So I don't think.
There's no way flash attention doesn't use FP4 though, right? Ever.
Well, gems do.
Gems do, yeah, but not flash attention.
Yes.
Yes, it uses it, or no, it doesn't use it.
It gems use FP4.
And flash attention uses.
BFs. I think it's BF16.
Yeah, it's BF16.
Oh, it's BF16. Okay, great. Even slower. Great. Cool. Yeah. So FP4 gem sound good. And yeah, let's get this stuff merged into master.
Sounds good.
Yeah, the investigation is closed on the speed. We're gonna get an air conditioner, or cloud machines by the time it's submission time.
Also, I'll just mention that a lot of the llama tricks depend on multi. And I kind of like don't want to touch multi while you're rewriting it, so maybe I'll wait by like next week.
A lot of the law tricks depend on multi.
So like the all reduce
Kernel,
cat stuff.
all reduce and
Yeah. Okay. I mean, multi's not going to change that much, but yeah. Okay. That's reasonable. Yeah, we can focus on FP4 this week.
Okay. So
Since Ren is here, you want to update?
Can you hear me?
Yes.
Yep.
Yeah, so we're running on hardware now. With test ops, test D type, I'm down to about like 10 tests failing, I think. I got tensor cores working too, got a little distracted because I found that WAMAs were failing on the emulator. So I'll need to finish that PR, hopefully if I have a time in a few days. I think basically what I'm trying to do now is get to a mergeable state where everything's working, but it's like pretty slow. So I'm just finishing getting XA6 test passing with regalloc and stuff. I was prototyping a decent weight count pass and dual issue ALU, like a couple of smaller perfs. But I think I'm gonna have to do some like decent control flow refactoring for the ISA layer, just to be able to merge at branches. Just looking at how LLVM does some of it, because I had dual issue and wait count working for
Yeah.
like half the tests, but it's just
don't
not clean.
don't worry about dual issue. Don't worry about dual issue ALU. I don't care about that at all. I actually ripped out a whole lot of the performance improvements in x86. We are not at the level where we should care about performance yet. We should only care if performance is egregiously slow for some reason. Right?
Okay,
Like,
so it is for the wait count because we're basically doing sequential IO right now. Like it just flushes all the
Oh.
outstanding instructions. I just do a wait count 0 after
Oh.
memops, so that definitely needs to be just because like I implemented a quick implementation and it was running quite a bit faster on gem, but a lot of tests were failing because of there's a lot that goes into a proper wait count pass. Like I said, merging at branches, you need better representation of
Wait.
like control flow graph blocks and stuff.
Are you putting are you putting a wait count after each load or a wait count after each group of loads?
Just each load right now, but I know I can
Okay.
do a group. Even with grouping, it's still going to be
No,
slow.
no.
Like
With
we need
group-
it to be.
Listen, with grouping, it won't be that slow. I think that's where we leave that for now. If you're doing it
Just
after,
straight 0. Okay.
yeah, you can do 0 after that. You can do 0 after the group, and that's fine, right? Like
Okay.
I want a gem kernel to basically be like, okay, we're gonna do a bunch of loads. We're gonna wait for the loads to finish. We're gonna do a bunch of math, and then we're gonna loop. That's gonna be decently fast. I wouldn't worry about optimizing beyond that. Again, always readability and low line count over speed. Most speed optimizations end up just falling out. They don't like they're not, oh, I need some very complicated paths to like make these choices.
Yeah, I mean the control flow is already a little dirty, like loop resolution and stuff, even for x86. And that's also been annoying for. I still have like 2 failing tests that are because of how I add source edges to alt loads. Because sometimes the alt load will get placed outside of the range, which causes problems. And because basically what I do is I just put the address in the source and try to hint for code gen.
Here's what you want to do for alt loads. You don't actually want to do alt loads like how they're being done. You want to do a rewrite pass beforehand that rewrites alt loads to gated stores.
Okay. Oh, yeah. I saw how x86 does that because it does a local load store, right? It creates new address.
x86 is terrible code. We want to move the rewrite pass earlier, right? So it's the same as the loop rewrite, right? Do you understand the range to loop rewrite?
Yeah.
You basically want to do that, but for gated loads to stores. In fact, you can rewrite all loads to stores, right? You can rewrite a load. A load is kind of like just an anonymous store. You can allocate a register and then you can do a store there. And this works on assembly backends because reg and ALU are the same address space.
Yeah.
But cool, yeah, no. Again, focus on those much more fundamental things. Then don't worry about dual issue ALUs. Don't worry about non-zero wait counts. Those are not going to get you that much speed.
Okay.
What is going to, yeah. A 0 wait count after every load will be really slow, but a 0 wait count at the end of the group of loads, it'll be fast.
Yeah, I mean, even some of the problems is with my addressing. Sometimes there's a bunch of loads that should be grouped, but there's actually instructions being omitted between them. So that's another thing is grouping them properly. I need to work on that too.
Yeah, I mean, instructions between them is fine as long as you don't have dependencies, right? Do you mean ALU
Yeah.
instructions that are using them? Yeah, then I would just fix that with a...
Mostly just addressing instructions. So yeah, I can probably just do an emit after the group. Yeah.
Well, addressing is fine, right? Because addressing doesn't have any dependency.
Yeah, it's not dependent on the loads. Yeah, that's fine.
Yeah.
Okay, so hopefully this week we can be almost mergeable. Like, I'm not saying you need to merge it, but like to the point where it's correct.
Sounds good. Yeah, WAMA is important. Dual issue ALU is not. And you should be getting WAMA kernels with Beam that are maybe 20% slower, but it should only be 20%.
Then LLVM?
Yeah.
Yeah, okay.
Yeah, I mean, I see no reason why a WAMA kernel should be slow.
Yeah,
unless there's
it's
something
all in
egregiously
the
slow.
instruction, yeah. Okay.
Cool. Yeah, no, you get a lot of like a lot of the reason you only need to wait at the end of the loop group is because you have warps, and warps will hide tons of latency for you anyway. But if you put it after every single load, the warps can't hide
Yeah, yeah.
latency anymore because there's more wait counts than warps. But as long
Well,
as you
it
have the
also,
same,
the other thing is I do it after a store right now, but it should probably just be before the instruction that uses the address, because that's the only dependency for the store.
I don't even know if stores need wait counts at all, do they?
If you reuse the VGPR that has the address in it, I'm pretty sure you have to do a VS count.
I will check that. I'm not sure. It could be
Okay.
either way.
It
I'm
have a
not sure.
dependency. Yeah. Okay.
Okay.
Yeah, I think that it does register scoreboarding, and I'm not sure you need that, but maybe do.
Anyway, the idea is write the correct thing, make it simple, make it looks nice, then worry about the actual speed at the end.
Yeah, and if you find yourself writing something that's like finicky and tricky, there's another way to write it. I don't care if it's 10% slower.
Do you want me to do that WAMA emulation PR? Do you want me to fix that soon, or does that matter? Because I
You can-
started that, and then I was like, maybe I should work on the back end instead.
You do things in whatever order you want. We don't have testing for int whammies. The emulator doesn't support them, I don't think.
Yeah, I fixed GFX 12 and RDNA 3, but now I need to just add scaled. I think it's scaled MFMA for CDNA is not in the emulator, and that's
Right.
kind of annoying. I was getting codecs to help me with that bit, but
Yeah. The emulator is slop code anyway. You can put more slop in it. It's slop.
okay.
The emulator is slop. I wrote the emulator with Claude. It was
It's the
slop.
idea.
Yeah, well, it's tests. Tests can be slop. What? I regret deeply ever writing slop.
I think you get
Timmy will clean it up.
I think you get the idea. And if you think something is totally broken on master, we prioritize fixing that. But otherwise, you just we trust you. You just like
Yeah. Whenever
prioritize
you want to
yourself.
get stuff merged. Yep.
Yeah. Okay.
Sounds good. And I mean, if you have any question, just post your like PR somewhere and say you have questions. Come on with
Yeah.
that.
Okay.
Sounds good.
Cool.
Is Kama happy?
Yeah. So they're interested in switching to IR3, although apparently with their new RL model, which got reverted, but it's probably gonna get unreverted.
No, it's unreverted. They found the lane change bug.
Oh, okay. Anyway, that is apparently slower with IR3, so we're gonna start testing that one.
If you add it somewhere, I will have my codec take a look or
So
whatever.
all the slowness is in that concat kernel. And in fact, if you go into onyx.py and you replace concat with tensorcat, and then you put contiguous on all of the inputs that concat, then it becomes way faster.
Great. Let's just add that to Open Palette hack and call it a day.
Want to add contiguous on those? Yeah, just add contiguous.
Yeah.
Yeah.
We already have a flag for Open Palette
Well,
hack.
yeah, but I
use that.
Sure. Yeah.
Or are you saying you are going to fix that? Open
I don't
Palette?
He can take 7, doesn't it? Like, he can take 7 to it. Yeah.
Okay, yeah. If it's only that, just add a flag, and we will worry about that later.
Well, I mean, yeah, I wouldn't make it totally non-generic. I wouldn't make it something that detects that kernel specifically. I would say, like, if I have a kernel that has, like, tons of inputs,
Yeah.
put contiguouses on all of them, and that can be an open pilot hack, and it's a rangeify rule.
Yeah.
It's 2 lines in rangeify.
Okay.
That's
Okay. All right. Yeah. Anyway, that kernel is always the kernel that causes problems. That's always the one that's slow.
Yeah, because why it's not? Because it's trying to fuse with the things above it.
It's fusing like 10 gems into a concat kernel.
Also,
They're all
that's a-
different shapes.
Also, that's also IR3 issue. IR3 cannot lower that properly.
No, it's not an IR3 issue.
But Qualcomm block
Like the
has no
ranges are all
problem.
just like totally messed up.
I see what it's doing. It can't like take like a global dimension across the things.
But Qualcomm compiler has no problem.
I mean, I think it's faster. I'll double check. I'm pretty sure it's faster for CL as well. But
Wait. If it doesn't improve it for both of them, I don't want to add open pilot hack. But if it
I'm
clearly
pretty
improved
sure
it for both of
I'm
them,
pretty sure it does. I'll double
Right.
check.
Yeah, I can believe that. Okay, great. I think that's it for this meeting. Anything else?
is Timmy downloaded?
Me day.
Oh, it's slow.
Oh.
Because
Everyone
everyone is
download
downloading
Timmy!
it.
Yay, Kimmy by tonight.
Just post somewhere when you are done downloading, and we'll see what we do with that. Cool.
Right.
Yeah, that's it for this meeting. Thank you, everyone. See you next week. Bye bye.
All right.